So we have on stage already Monika Schnitger. She's President and Principal Analyst of the Schnitger Corporation. And of course, we have Crystal de Rouvray. She's CEO of the ESI Group. Now I'm very happy to hand over to you and enjoy the session.
Thanks, Manuela, and thank you, everybody. Good morning. I know that it's very early for Christelle, but everyone else, happy day, good morning, good evening, good afternoon. The purpose of this session is going to be a customer panel as soon as we get Javier's audio sorted out. But for the moment, Christelle and I are going to chat about what she is seeing as issues that her customers are facing, all of you, and try to set up the customer panel, which will immediately follow. So good morning, Christelle. Are you ready?
I am. Can you hear me?
Definitely. Absolutely. So let's start with a general kind of question. ESI works with so many companies and across many industries and geographies. What's challenging them the most? Is this supply chain issues? Is it product innovation? What are you seeing when you talk to your customers?
Thank you, Monica. Thanks for joining us at ESI Live.
Oh, you're welcome.
So I have 3 words for you: clean, safe, and productive. And why are all of the customers that I talk to and the industries that they serve, and the industries, sorry, that we serve, why are they all resonating with these 3 words? It's because of the mega trends at hand. So summarize it in 2. Hi, Xavier, we can hear you. Sorry, this is the joys of online conferencing, and we're all getting really good at it. So 2 mega trends at hand. First one has to do with environmental impact. So there isn't a customer that I speak to, there isn't a press release we write that doesn't address the big elephant in the room, which is to reduce our collective environmental imprint. And that goes with reduction of the carbon footprint. So you're going to hear from the automotive industry in our customer panel today. You're going to hear multiple examples of how front and center this is. And so I'm just going to perhaps add a couple auto examples that have inspired me recently. So with GM, the very impactful 0 emissions, 0 crash, 0 congestion. I think that says it all. Nissan recently announced that they plan on reducing their carbon footprint by 90% by the year 2050. But I should probably cite other industries as well, because this is not just an automotive trend. In aeronautics, Boeing and Airbus recently announced that by mid-2030s, they will put in the sky, they will put to fly a commercial aircraft that does not rely on traditional fuel. And so, think about it, mid-2030s, that's when my children, very soon, that's when my children will be in their 20s. And what that means is that mobility, right, whether it be in the sky or whether it be on Earth, that mobility for them is going to be very different than it was for me or for you growing up, and different in a good way. And that's possible because the energy industry is thinking itself totally transformed, right? We are collectively thinking energy differently. So here I have an example from California, where I live, which is why it is very dark here, because it is very early. But an example from California is that we recently started working with a green energy player who is figuring out how to not only produce green energy, which we've been doing as a society for decades, but it's figuring out how to store it. And imagine football-sized fields of batteries, so that we can have a more efficient electric grid, right? We can have a grid that's powered and that is equilibrated with green energy. So as if this were not hard enough, right? This first megatrend, which is to reduce our carbon footprint, we need to add a second megatrend, which has to do with the growing demands on productivity. So here I think I have an example that's going to speak to this. Just in the past year, so since January 2021, the costs of energy and of materials have skyrocketed because of bottlenecks in the supply chain. So they're 5 times higher on average than they were at the start of the year. So you put these 2 things together, you put the demands on productivity and competitivity. You put together the demands on, environmental footprint, and you have a situation where industry is asked to be more competitive and more sustainable than ever. So I believe that simulation and virtual prototyping are key instruments in squaring this circle. So our role at ESI is to stand by our customers and help them navigate what has now become this new normal.
Oh, that's brilliant. Let's flip to ESI for a second, right? You and the management team developed the One ESI 2024 strategic plan. Can you describe to us what that means for customers, and what should they expect from ESI, given what you've just articulated as the challenges that they're globally facing?
So One ESI 2024, right, is a new and exciting journey that is centered around our customers. So this means we are building up our capabilities to help them achieve their clean, safe, and productive objectives. So how are we getting there? We are refocusing and reorganizing ourselves to allow for the development of more integrated and more user-friendly software solutions. So concretely, immediately our customers can expect the best suited accounts team for them, drawing from our talent pool locally and globally. So that's why we call it One ESI. They can also expect collaboration with their software ecosystem for more data integration, for more efficient product development. Also immediately, our customers can expect that we are investing right now into the infrastructure that's going to enable us to generate these more integrated and user-friendly software solutions. So very concretely, better user interface. And what do we mean by integration? So we at ESI, we have this word, we call it chaining. That's the word we use to make very domain-specific, a generic word that would be called integration. And we have a platform, a software platform for chaining. So chaining means the ability to connect previously siloed elements in the simulation workflow. A couple examples will make this very tangible. First, if you want the answer to how safe is my automotive cabin, you have to be able to simulate both the impact, right? So the absorption of the impact, the structure, and the explosion of the airbag inside of the cabin. And we have been doing this for at least a decade with many of our key customers, but it's literally a chaining of two different types of simulations. On the one hand, you have structure, on the other side, you have fluids, and then fluid structure interaction. So the physics backend that enables us to do that is a differentiator that ESI has invested on over the years. The platform, the software platform to be able to do this at scale and on other holistic problems like the one I just described is where we're going to be putting our energy. So let me give another example. We're quite known for this expression called weld to crash. And that is absolutely a chaining exercise. But to take that kernel called weld to crash and to blow it up so that or expand it so that it answers one of the biggest biggest questions when we are collectively trying to tackle environmental imprint. That big question is weight of the craft, whether it's an auto craft or it's an aircraft, right? Weight has to do with the choice of materials, and then the fabrication of those parts, the assembly of those parts, and ultimately testing that they meet the performance, the outcome criteria. And so this sector in particular in the automotive sector, of taking lightweight materials and then thinking through the whole continuous assembly process is fundamentally a chaining problem. And that I'm very excited about the energy, the priorities we've put around this so that we can be a credible and valuable partner for our auto OEMs as they embark on this continuous manufacturing journey.
Chaining sounds, I'm sorry, go ahead.
I was just like a quick sum up. This platform for chaining is a prerequisite for us to be able to bring these integrated high value solutions to our customers.
Sorry, I got excited about the chaining. So the plan gets you to 2024. What do you see simulation and ESI being and doing after 2024? I mean, things will keep going. So just say in 2030, where do you see ESI and simulation?
So for all of our customers, 2030 is already today. I've had numerous conversations where people tell me that the decisions they're making right now are going to determine whether they're still growing, they're still in business in 2030, 2040. So the urgency of tomorrow is today's concern, I think, for all of us. And this was definitely a motivator for our one ESI plan, is to take the right decisions now so that we are a vibrant and a helpful player in the decades to come.
Terrific.
So as a result, many of the trends that we're experiencing today are just going to be bigger and more present, right, in 2030. So I've identified two for you. The first is what we call virtual certification, or currently virtual pre-certification. So as you're going to hear from our panelists today, they are already living in a world where the virtual model is the reference point for making their decisions. So wouldn't it be nice if the regulation agencies pave the way so that we can start making decisions at a societal level on the virtual environment or on the virtual reference? So that is my first thought, because the benefits would be immense for us as societies, right? As we really tackle with these dual competing constraints of productivity and environmental impact and sustainability. And then the second is predictive maintenance. So we're already all anticipating and working on software solutions that enable us to make better decisions as the asset is being operated. And I expect that by 2030, this is going to be much more mainstream. And we at ESI are investing in what we call hybrid twins, which is basically taking the mega power of our predictive virtual models, and that's the reason why our customers can use the virtual models as their main reference, to take that mega power and marry it with the minimum viable amount of data, so smart data instead of big data, to be able to generate solutions for these predictive maintenance questions. So virtual certification, predictive maintenance, that's what that's what we're going to be contributing to bringing to bear by 2030.
Awesome. I think that is exactly the right direction. But we need to switch topics just a little bit. What are you most excited about at ESI Live 2021? Topic sessions, things like that, and then we will switch to our panel.
So I'm just grateful that we get to run an event like this, that in spite of the fact that travel is still highly constrained and that in some ways we've all learned to work differently, we take the moment to gather and celebrate our customers' achievements that we've helped in a modest way, that we've helped contribute to. So I'm just glad that we're in community. And what I did want to let everyone know is that, Monica, you and I are going to be back at the end to close out this conference with highlights on what we've learned during the conference. So I hope that you join us then.
Well, terrific. Thank you so much, Christelle. You've given us a lot to think about, but it is time to segue into the customer panel. So, excuse me, I'd like everyone to join me, please, in welcoming Seat, Stellantis, and Volvo to our panel. Could you please unmute yourselves and turn on your cameras? And Javier, are you able to hear me?
Okay.
And oh, perfect. Yeah. Great. Okay. So specifically, please welcome Jesper Linder, who heads digital and IT within the Quality and Engineering Group in Volvo Group Truck Operations. Javier Castillo, the Manager of Functional Development, CAE, in the Body in White and Interiors Development Department at SEAT R&D. And Ciro Maia, the Virtual Engineering Site Lead, Latin America at Stellantis. Let's start here. Ciro, tell us a little bit more about what you do at Stellantis and how you got there, and then maybe from there, segue on into what Stellantis sees as its main business and design challenges and how simulation helps mitigate these risks. Okay. Welcome.
Welcome. Thank you for having me here. I'm the Virtual Engineering Site Lead for LATAM, and in my team we have the CA engineers responsible for modeling and model build, multidisciplinary optimization, NVA, safety, aerothermal, CFD, virtual load generation, and durability strengthening use. It's a big team. We are in charge of the virtual development and validation of the product's performance. And I have been in company since 2008. During those 13 years, I had the opportunity to work in many different areas on virtual engineering. And in 2018, I became the site lead. Your question is very important because we use virtual tools to facilitate development, and we leverage on it to achieve our targets. The automotive market is one of the more complex and global integrated that I know. And virtual tools make this complexity manageable and sustainable. I believe that without simulation tools, it would be impossible to meet the regulatory requirements and customer expectations with a financially feasible product. On top of my mind, the main challenges are safety requirements and emission regulations that are specific for each country and region. And from the customer's perspective, there is a growing expectation from a more connected, green, safe, and performatic vehicle. From the business perspective, there is a escalate of cost for raw material, for example, and we have to work hard to keep it under control and do our best. And also there is a challenge to couple the tight timelines with the need for innovative products.
No, absolutely. All of those are absolutely, I think, what we're seeing across industries. How about you, Jesper? You've had such a varied career. How does that help with the challenges that Volvo Trucks sees?
My variation of the career and background, I think, have helped me in many ways, especially for running my own company and startup for some years before entering to this, you could say, on the corporate side of things. Then Volvo is big, huge. I done many different things within Volvo as well, and it's a good company to work for from that perspective. So I've been in sales and aftermarket and worked with volumes and forecasts, etc., before moving into the position where I am right now, then within quality and engineering.
And what does Volvo Truck see as the biggest challenges that it's trying to overcome? And how simulation helps, to be honest?
For us, right now it's the diversity, and increased diversity going into the technology shift. We have always done mixed model assembly. We will continue to do that, but to a larger extent. But the challenge is, of course, to maintain and keep our, you could say, effectiveness in our production facilities. And to bring one challenge related to this, of course, is the human aspects of ergonomics and to make sure that we have health and safety first for our operators, and there we use simulation a lot.
Oh, absolutely. That leaves Xavier. Tell us what functional development is and how your team, what your team's main business challenges are, and of course how simulation helps there.
Yeah, hello everybody. I'm in charge of the development, function development department. So we had to develop the functions in crash simulation, stiffness, CFD, and also interiors, occupant safety, and vehicle acoustics. Okay, we are completely aligned with the Green Deals, and okay, our contribution to these Green Deals is the development with this process, with the virtual development process, no?
Javier, what are green builds?
Yeah.
What are green builds? Can you tell us more about that?
The ecological Green Deals and totally aligned with the Paris agreement. So
okay.
I have some problems because I'm hearing myself. Okay, but I'm trying to, and it's complicated to speak here. I'm trying it. Okay.
Okay, well, you're doing great. Thank you very much. Let's move on. One of the things that I find fascinating about your companies is that you have been working on digitalization for a very long time. Can you talk a little bit about how your company's digital world has changed in the times that you've been there? Jesper, maybe we start with you. How has your company's use of simulation changed over the years, and where do you see it going, say, in the next 5 years or out to 2030, if that works?
If you start with digitalization in general, I would say when I came into Volvo, I was very impressed with the level of automation, especially within our component factories. I think the difference from then to now is that we have a lot more digitalization, you could say, it's in each and every one. And of course, where we have citizens development or utilizing our tools to a much larger extent with a lot of more data available that we had before I started. But so coming more from a modular landscape more to digital layers and cloud-based, and I would say that is the main difference since I started.
Mm-hmm, mm-hmm. And Ciro, how about?
Yeah, if you want to go with simulations in particular, or?
Sure.
Yeah, so I think when you look back, it was a lot of effort to get simulations done for getting a lot of data that was needed for the simulations, quality of data. So we are more effective today, but we still have a good journey to go before we are where I would like us to be. Yeah, we're better, but we work more with moving on with more of seamless integration. It's not be that dependent on experts. That would be my wish and when we look forward.
Sure, sure. Ciro, how about you? When you talked about virtual builds, right? So when you think about how your company is using simulation now and in the future, how do you see physical versus virtual tests? Where are you in that path, and where do you think that you will ultimately wind up, and how will the industry in general and government help with all of virtual certification and those kinds of things?
Okay. During the last decade, we had many breakthroughs, right? Digital twins, cloud computing, and so on, virtual reality, so on. And that helped us to develop a mindset, and it's actually a change of mindset to consider the virtual environment, the common work and development environment. And this is very important for us because it allowed us to establish a culture that the vehicle must be developed and validated on the virtual environment before the tooling kickoff. So the virtual test, indeed, is a confirmation of the decisions already made on the virtual world. So they are complementary of each other. We still need a lot of data to feedback the simulations and develop it to get more accuracy and better correlation. But at this moment, our decisions are done from the management perspective and from the technical perspective on the virtual world. And this is a big change. It's a big change. It's nice to look back and remember when I joined the company a little bit more than a decade. And we used to have meetings discussing over drawings printed and plotted in the wall. It's unthinkable nowadays. It doesn't happen anymore. It's everything digital, and it's everything much faster, and from my perspective, more efficient also.
Javier, do you feel able to answer a question, or is it just
of course.
Okay, because I think that from when we spoke earlier, the new Cupra four-mentor model caused SEAT to change how it approached regulatory crash safety and testing in general. What were you trying to do, why, and sort of what KPIs were you able to achieve with a four-mentor model that you couldn't do before?
Yeah, for example, we are able now to fulfill some regulations only with the simulation. And our opinion is that this fulfillment only with the simulation must be exchanged and extended to other disciplines. Okay, and we are prepared because we have a very good quality in the models. The simulation models are very reliable, and the correlation with the test is very good. Thanks to the collaboration with ESI, with our on-site support, and with the rest of the W group. So regarding the physical test elimination, we are now in the point that not for the Formentor, but for our current development project, we don't have any prototype anymore.
That's awesome.
Okay, so we are using the physical vehicles in order to follow up the industrialization process. Okay, we can differentiate between prototypes, and prototypes are objects that are used before the final release of the project, and the physical testing vehicles, the pre-serial testing vehicles. So our goal is to use these physical testing pre-serial vehicles only to follow up this industrialization process till the launch, the final launch of the vehicle. Okay, in order to avoid quality problems or to improve some production issues. Yeah.
Christelle, thanks for coming back. Are you able to hear and speak?
Yep.
Oh, great. Okay. 2 questions for you. ESI just announced a new phase in the relationship between ESI and SEAT. Can you tell us more? And then topic switch, can you tell us more what you're seeing across industries in terms of the validation becoming more, if not exclusively, digital? So start where you wish.
I mean, I think I'm just going to repeat what Xavier said. I mean, so the press release that just is hot off the press emphasizes the 5 stars in terms of safety. So remember, clean, safe, and productive, with the numerical as the reference, right? No more prototypes. Now the what you call it, the physical serial, in order to follow up with the manufacturing, that's become the next frontier. And that next frontier is what I was alluding to when I was talking about automotive assembly. We're ready to tackle that next frontier. So I think what's really exciting about the press release that came out is that we're all, we share common goals, and we're feeling courageous about our ability to tackle them together, because we've already made it through this first milestone. Which I can echo in Ciro's and in what I heard from Jesper as well. We already have the mindset ready to think about virtual as the main reference and the benefits, the associated benefits.
Okay, absolutely. And sorry, Javier, did you want to chime in?
And we can go forward in this situation that only to use the pre-serial series to follow up the industrialization process, no? In order to eliminate or to reduce these pre-serial cars, we must still improve the methodologies, no? Not only on the development phase, but also on the production, for the virtual factory, I mean. Okay, so in this moment instead, we are working in introducing in our development process artificial intelligence and machine learning methodologies in order to give to the project more robustness, in order to avoid, for example, unforeseen or unexpected behaviors in the tests, in order to fix the uncertainty that we have not only in the simulation but also in the test. And we can introduce these methodologies thanks to the reliability that we have with today with the models, with the simulation models. And we can go forward with these methodologies, artificial intelligence methodologies.
Absolutely. Christelle, can you kind of take us to other industries as well? Is this something that you're seeing only in automotive, or are you seeing this in heavy industry and in aerospace? And I mean, I am, but I'd like to get your take on it.
No, it's absolutely a marker of I'd say all industries that tackle complex industrial assets. So I think we're talking here about the governance shift, the mindset shift that goes from using the physical asset as or the physical test, the sequence of physical tests as the main thing you need to govern, towards shifting the attention towards the virtual sequence as the main thing you need to govern. And so I'll take a couple examples from aeronautics. So Safran has, we have videos, I'm sure if you search on YouTube, you can find them, but you hear Safran testifying to, or their testimonials around how they have baked into their governance process reviews, immersive reviews into their tooling assembly processes, right, their tooling routines. And that is now the reference. And it's the reference because they can bring in so many different stakeholders. I think Jesper was saying something like, trying to emancipate from dependency on experts. Experts are always needed. However, bringing the ability to bring in the other constituents, right, the people who are going to be working in the tooling station, the people who are going to be designing the tooling station, that ability is critical for making the right decisions. And it came home really very concretely for me when I heard another aeronautics player whose name is LATAM talk about why the immersive virtual experience was so much more effective. It's because this is sort of a basic human cognition model. We only remember 10% of what we read, 20% of what we say, and 90% of what we do. And the virtual environment, in particular in its immersive, is much closer to doing than it is to reading. And so you get a sense of why it is that we're experiencing these gains in productivity and why we as a collective are shifting our governance from physical to virtual. And in particular, in a totally globalized world where anyways, the idea of gathering a whole bunch of people who fly in from all different parts of the globe is becoming less and less realistic. It's not just an alternative. It's a great thing that, thank goodness we have this, right? And we definitely saw it during COVID. We saw. I mean, talking about heavy machinery, and I think maybe Volvo wants to talk about that. But we saw people moving their installations into their garages so that they could continue running the immersive sessions. Maybe Jesper, you want to say something about that?
I didn't really catch it, Christelle.
I'm sorry, maybe I was speaking too fast, but I said that some of the heavy machinery players who are so reliant on these immersive sessions to validate assembly, during COVID, since you couldn't go to the office, you found a way to bring the installation into a COVID-safe place.
Yeah, definitely. We have learned a lot during the pandemic. Now I'm more into the truck part of Volvo and not so much into the heavy machining or construction equipment. But of course, even at us, we have needed to twist and turn during the pandemic to utilizing a lot of digital tools to both to collaborate and also to continue with our different installations, doing it remote, not with traveling. Of course, it has been a period. It has been really challenging, and it has been tough for many. But there's also positive things coming out of this pandemic, and this is one of the things. We will be more sustainable, and we will be more quicker. We will have less need of traveling, and it will not completely replace it, but we will reduce it to a big extent.
I would like to, that is fascinating, but I would like to return us to governance for just a second, because I know that one of Ciro's focuses at Stellantis is what Stellantis calls the performance full scorecard. Ciro, can you tell us what that is and how that works in your context, and maybe what other people can do that's similar?
Okay, it's one more demonstration of how digital we are, actually. The program management uses the Virtual Scorecard to decide and approve the goal of the program. And so some years ago, we used to concentrate a lot of energy on managing, on the governance, actually, of the physical test milestones which were updated to the virtual world. So the virtual scorecard defines complementary waves of virtual analysis and virtual validation and give us the full picture of the program. The starting point is usually a pre-CAD and morphing, where we evaluate the concept that is born with the requirements and the brand requests. The subsequent waves are focused on the product development itself. So we first certificate the architecture's components, then the architecture itself, after that the vehicle's components, and finally full vehicle performance. And in order to guarantee the governance and the status of the plan, the execution of the plan, we present it weekly in a core meeting with the whole team involved in the project. The REDs are discussed, tracked, and an action plan is built. Everything based on simulation. And the final check for the tooling kickoff, the component has to be full green on the scorecard, and we make a final cross-check to see if the specifications that are going ahead match with the CAE model to make sure. It took us some time to refine and fine-tune this process, but the benefits are many. The false positives due to misalignment were really eliminated.
Oh, that's good.
The level of awareness, confidence, and comprehensiveness of the design has increased a great deal. And we do not see the physical tests as part of the process development anymore. It's a confirmation after the process development that was completely done on virtual world with virtual tools.
So do the scorecards sum up? So component to subassembly to bigger subassembly to subassembly to ultimately the full vehicle? Or is this at the component basis?
It starts at the component basis and then sum up to the full vehicle performance.
Okay. And how do you do the management of the fact that there are so many variants in each car that you produce?
Oh, this is a great thing. First of all, we are working to try to reduce the diversity of so many variants, because it means sometimes cost and not value.
Sure.
It means cost for production, development, everything, and sometimes the customer doesn't see this value. So the first effort is to reduce this diversity and to filter and to eliminate what is not delivering value to the customer. The second part is to map on the first wave, the critical versions. So even before the product itself we have only sketches and targets, we can map based on previous programs, based on previous simulations we have done, based on experience, what should be the critical versions. So we start the development with those critical versions, and from time to time, each milestone, at the end of the milestone, we confirm that the other version that we have not dedicated so much time and effort is doing as great as the critical version. So after each milestone, we have the simulation to confirm that all variants are okay, good to go. But we tend to dedicate more time and effort to develop the critical ones.
No, that makes absolutely great sense. We only have a few minutes left, so I would like to give you guys the floor to talk about whatever you want, because we've talked about so much potential. You've made great strides, but you've all identified things that you would still like to do. So what are the final thoughts that you might have for our audience? Javier, do you feel like you're able to talk about that? Or I'm not sure what your audio issues are right now.
Yeah, I have some problems, but I can do that.
Okay, good. Then please kick us off. What final thoughts would you like our audience to have?
We are now in the point that we are reduced completely the prototypes. Okay, our goal now is to reduce to the minimum the procedural vehicles in order to confirm the industrialization process, as I said before. So for that, we need the implementation of artificial intelligence methodologies in order to give more robustness to the simulation process and also on the production side, we must enhance the virtual factory also.
Jesper, how about
this leads?
I beg your pardon. Please finish, Xavier.
Yeah, please.
Okay, I was just going to say, Jesper, how about you? What do you think Volvo Truck is thinking about most right now, and what would you like our audience to take away from your thoughts today?
I think it is a bit different from my colleagues here online. I would say for us, it's to continue the path of the cross-functional value stream approach. On the soft side of things, it has a great value, what we have done, and that's a journey that we will continue in many different areas.
Terrific, thank you.
Yeah.
Was there anything else?
No.
Okay, well, Ciro, how about you? You talked a lot about the kinds of things that you are trying to do. What final thoughts do you have for our audience?
Well, I see two big opportunities to unlock value from the simulation perspective and help even more the development. The first one is we need to reduce the time for model building. We need to develop as soon as possible a seamless process connecting CAD and CAE to speed it up and be able to evaluate it faster with more trials and errors to learn earlier and make it better earlier. The second one is the use of artificial intelligence and machine learning. And it's a bit fashion to talk about that nowadays, so we need to be careful. I believe in the near future, we can use it to predict even more the results, to improve the accuracy of our simulations, and to move from a deterministic approach with safety margin to a stochastic approach, especially heavy workloads of multidisciplinary analysis.
That's brilliant. Christelle, would you mind if you and I save up our thoughts for the closing session? Okay, good. So I would like to thank our panelists very much. You're getting a virtual hand clap from our entire audience. Thank you very much, Xavier, Jesper, and Ciro. And please, and also, of course, Christelle, please stick around for the rest of the day. Coming up next, you can join the live interactive virtual reality demo to see how to validate product integrations. Not yet with the chaining, but virtual reality anyway. You can network with other attendees, as Manuela explained. That's the networking button on the left side there. Or you can check out the videos that are demonstrations of ESI products. That's the bottom of the left side there. At 3 o'clock Central European time, so in about 15 minutes, the event splits into 3 parallel tracks, one each for automotive, aerospace, and heavy machinery industries. And as Manuela explained, all of that can be accessed from the buttons on the left side of the screen. After the industry tracks, as Christelle and I teased, at 4:45 Central European time, so that is in, hang on a second, 2 hours, we will all come back together for the closing plenary. So please, in the meantime, enjoy the event, and we'll see you in the closing session. Thank you so much. Manuela, did I leave out anything?
No, you were great.
Okay.
Mentioned everything. Thank you very much.
Thank you, panelists, and we'll see you in a little while. I really appreciate all that you've done today. Thank you.
Thank you for having us.
Thank you.
Thank you.
Thank you for the opportunity. Bye-bye.
Bye-bye.